Okay, in this video, we are going to look at question 9 of the WJC Additional Maths paper from June 2015. And this is an integration question. So before we do any integration, let's just remind ourselves of what we have. So x to the n will integrate to, so we raise the power by 1 and divide by the new power. So you can either divide by n plus 1 and write it like that, or you can write it as a multiplication of 1 over, which I quite like to do. So we get 1 over. Now, if we do have a product, then we end up with that product on the top because we end up with that number multiplied by 1. Okay, so the first thing we do when we're going to integrate is we make sure everything is ready and in integratable form. So that means we want it in the form of something times x to the n. The first term is fine. The second term is fine. The third term is not, because my x to the n is on the bottom of a fraction, so we need to deal with that. And the last term is fine. So I just need to rewrite this one. But it's important that we don't actually do any integration until everything is rewritten. So this should be written as the integral of 21x to the 6 minus 3x squared minus, okay, so 1 over x squared becomes x to the negative 2. If you're not sure why, please check out my videos in the main website, plus 6, and there should be brackets around it because it does come from multiplication. So we should have brackets around that. And now we can use our integration skills. So for my first one, I have 21 x to the 6. So x to the 6 is going to go to 1/7 of x to the 7. Okay. Now, 21 times a 7th is 3. So a 7th of 21, if you want to think about it that way, divided by 7. So that's 3x to the 7 for my first one. Okay, the next term is minus 3x squared. So I'm going to get negative 3 multiplied by an x squared will integrate to x cubed over 3, or a third x cubed. The 3's will cancel out on the top and the bottom, so I'm left with negative 1x cubed, or minus x cubed. Okay, the next one I have negative 1 technically, multiplied by x to the negative 2. So that's going to go to x to the, and we have to be careful. If we raise that power by 1, it's negative 1. I'm going to divide that by negative 1, or write it as 1 over negative 1. So now we have a negative multiplied by a negative, so that's going to cancel completely, making it positive, and I'm left with 1 lot of x to the negative 1. So I get plus x to the negative 1, and then the plus 6, any constant, will integrate to that number of x's, so we get plus 6x, and then we have our constant integration plus c. Okay, part B. Showing all your work in, evaluate this. So whereas the last one was what we call an indefinite integral, where we don't have any values, here we have a definite integral. We're actually trying to work out an area between 2 points. Again, there should be brackets in there. WJC have chosen not to, but there should be brackets there. So let's try this. First things first, we make sure that both of these terms are in integratable form. They're both in ax to the n form, which is brilliant. So first things first, I'm going to integrate. So if I take my first term, I get 6 times, well, x squared integrates to a third x cubed. 6 thirds are 2, is 2. So the first one is 2x cubed. Oops, change pen. 2x cubed. And the second term, the plus 4x, is going to go to plus 4 lots of, well, the integral of x is x squared divided by 2, or a half x squared. 4 halves are 2, so that's 2x squared. So plus 2x squared. And we're going to integrate those between 5 and 2. So we're going to substitute in our upper limit first. So that's going to be 2 lots of x cubed is 5 cubed, plus 2 lots of x squared is 5 squared. And all of that I'm going to subtract what I get, just scooch this over, when I substitute in 2. So I get 2 lots of 2 cubed plus 2 lots of 2 squared. So I'll work out each bracket separately. So there's 2 lots of 5 cubed plus 2 lots of 5 squared. So the first bracket is 300 minus, so I change all the 5s to 2s, 24 should give me 276. And that's the answer.